All right. Thank you for the introduction, Ben, and good morning, good afternoon, good evening, everybody. And thank you for being with us today. Today, we're going to talk about magnetic ranging technology and services. But before we get into the details of the magnetic ranging, I would like to talk about conventional surveying, since conventional surveying, such as MWD or gyroscopic surveys, and ranging, both designed for wellbore navigation. So let's talk about problems with conventional surveys. And here in front of you, you can see three planned well paths. They look like simple curves. In reality, the actual well position may be anywhere within the cones of positional uncertainty of these well bores. This uncertainty is due to the errors in reference information and survey measurements and the tool alignment with respect to the well bore. The errors expand as we move farther away from the point of survey origin due to the dead reckoning calculation technique, where multiple small errors in measure depth, inclination, azimuth result in significant errors in 3D wellbore position. These errors can be minimized, but unfortunately, they cannot be completely eliminated. In saying that, let's talk about what magnetic ranging is. Magnetic ranging uses precision sensors to detect and analyze a magnetic field from a ferromagnetic source or electrical current in the offset wellbore in order to calculate distance and direction to that wellbore. To do so, we need to have a magnetic field source in the offset wellbore, and the source can be residual magnetism from the target well casing itself. In this case, the ranging is called passive ranging. At the same time, we sometimes may want to energize the target well casing or place another active source in the offset wellbore, such as electromagnet or permanent magnet, or inject current through the formation that it and energize the target well casing. And in this case, the ranging will be called active ranging. And we need the receiver to detect this magnetic field from the offset wellbore. And the receiver can be, in many cases, just MWD sensor package, but sometimes we require to run wireline sensors in the offset wellbore, and it can also be surface sensor package sometimes. And here I just would like to visualize what we discussed so far. So with conventional surveys, uh, the Earth with its magnetic field, with gravity field, and the spin axis is enough, plus additional reference information is enough to provide absolute position of the wellbore in space. Magnetic ranging is different. In case of magnetic ranging, actually, the static field from the Earth and all other background noises is the error source. So magnetic ranging creates another layer of magnetic field on top of the background field, and we detect that additional field from the ranging with the ranging receiver. So with magnetic ranging, we do not provide the absolute position of the wellbore in space. We provide reference position of the offset wellbore with respect to the reference wellbore. And why do we need this all? Again, as you already know by now, conventional surveys may be uncertain. They are uncertain. And in some cases, the uncertainty may reach hundreds of feet. But imagine right now you need to connect two well bores, and one of the well bores is few miles away from you. Uh, Using just conventional survey techniques may not lead you to successful intersection from first, second, or third attempt. But using magnetic ranging, you are able to energize the target well or the source in that target well, so you can directly navigate into that target and connect the wellbores. Or sometimes you just want to make sure that you avoid collision with the existing wellbore. Instead of connecting wellbores, you may just want to drill around it and make sure that you pass by it safely. So ranging applications: plant well intersections, including relief well intercepts, plug and abandonments with eccentric reentry. And in fact, we do lots of this job. We have two jobs running at the moment, and we even released a paper about how we did one of the projects with complex abandonments. We released this paper for AADE, and you can download it for free from the aade.org. So I encourage you doing so because you can learn more details about our ranging methods. And so, what this eccentric and complex abandonments is when, for example, there is no way for you to access the target well from surface because there is a restriction, you may need to drill another wellbore to re-enter the target wellbore eccentrically, and this is where magnetic ranging helps. So, other applications can be related to complex completions or ultra extended ridge drilling. You can also do proximity drilling management with ranging, and this would include collision avoidance, fish bypass, multi-well pad drilling, offshore drilling. And another thing that you can do with ranging is precisely space your laterals in shale plays. And we also released a paper not long ago where we explain how magnetic ranging can be used to precisely measure the distance between multiple laterals uh, in order to provide um, reliable information for frac hit models. In fact, frac hit models require information between the distance between wellbores, because that's part of the calculation, and uncertainty between this lateral wellbore, in spacing between this lateral wellbores may lead to uncertainty in the frac hit model. So, ranging types. Ranging can be access independent. This is where there is no access required to the target wellbore, and it sometimes can be restricted. The access may be restricted physically. There is no access to the surface location of the target wellbore, so we have to use a ranging method that does not require the access to the target. And the first method I would like to talk about is our main method in the toolbox. Is called Black Shark, and this method is related to formation current injection. It is a highly accurate wireline active ranging, which is capable of gradient magnetic field measurements. And in this case, the wireline tool is deployed into the drilling well with the current injection assembly, and the target well is being energized from the drilling wellbore. Another method is called Syntrack, and here we are energizing the well from surface, but we can detect the magnetic field from the target well with a standard MWD system. Another method, MagTrack. This is actually passive magnetic ranging method, and since with passive ranging you don't need to actively energize the offset wellbore, this is also access independent, and it does not require additional equipment on site to do passive magnetic ranging measurements. There are also access-dependent methods, and in this case, access to the target wellbore is required, but at the same time, this enables longest detection range. And one of the methods is based on the electromagnet deployed in the offset wellbore, and the receiver in this case is a standard MWD system, and we call this method MagTracer. Another method in access-dependent group is lodestone, and this is at-bit well drilling ranging. So this is the method with the largest detection range that we have in our ranging toolbox, and this is at the same time one of the most accurate methods. And the benefit of this is that the measurements are collected at the bit of the drilling well, and the receiver. So the source is at the bit of the drilling well, or near the bit, or in the BHA, and the receiver is placed in the offset wellbore. And let's talk about the most important of these methods in details. So active magnetic ranging method Blackshark. The wireline deployed in the drilling well. The tool string includes current injection assembly and the sensor assembly. The sensor assembly collects sensors, array of magnetometers, and it also collects accelerometers and gyroscopes to measure magnetic field and gravity field and earth spin rate. And so this tool provides distance and direction from open hole to the target well casing. Again, the access to the target well is not required in this case, which makes this tool perfectly suited for plug and abandonment applications and relief well applications. Another method that I would like to talk about right now is MagTrack, passive ranging. In this case, we use the residual magnetism of the casing to determine distance and direction between well bores. And we complement this method with continuous B total and BZ measurements for early magnetic anomaly detection, which means that if the SDI MWD system is ran on the location, we are able to transmit the continuous B total live to surface, so we can see as we get closer to the offset wellbore, and we can identify the areas where we would like to do ranging, and or in opposite case, we can just avoid getting close to the offset well and just steer away from this. So to do ranging measurements in this case, we need to collect 6-axis MWD shots along the anomaly in order to process this measurements as ranging shot. And in case if only passive ranging is used on the job, there is no need for the SDI personnel to be on the location. All analysis is performed remotely, and the report which will be generated provides distance and direction to target in different formats relative to the measured depths of the ranging. At this point, I would like to talk about gyro survey integration with our ranging. And it is integrated with our passive ranging methods and with active ranging methods. In fact, survey data is required for ranging calculation. And why is that? It is because if there was no survey data, the ranging shot would provide us the information about distance and direction to the target in the ranging tool's XYZ coordinate frame. But this is not very helpful for the directional driller. So this information needs to be rotated to the northeast vertical coordinate frame using the survey information from that wellbore at that particular ranging depth. So we can consider the ranging tool as the complex, sophisticated magnetic survey tool. So of course it can provide you with magnetic survey information, but usually when we do ranging, we're close to the target, which has casing, and it creates a magnetic interference for that magnetic survey. So magnetic survey has poor quality for this reason. Also, what might work is the prior survey from this ranging well, from this sensor well. And this would be all right, but if the sensor well is vertical, so we may realize that our prior gyro survey in that wellbore may have different orientation from the ranging tool, which is ran in this sensor well. So here you can see that the gyro tool on the previous slide had different geometry. So the azimuth at the same measure depth in this sensor well was different from the current azimuth of the ranging tool. So again, in vertical scenario, this will not provide accurate ranging orientation information. But what we do, we combine gyro and ranging systems together. So we get one system which includes all sensors, and in this case, both modules are aligned with each other, and the in this case we get precisely accurate orientation for ranging shot from gyro from gyro tool. But at the same time, we collect a lot of gyro surveys every time we run ranging, which is great. And so what we get at the end is the higher quality data, which results in fewer ranging runs. And here I would like to show you the comparison between ranging shots in the vertical well with gyro orientation and without gyro orientation. So you can see that the ranging without gyro is significantly scattered around, while the gyro-oriented shots are much more consistent. And this point, I would like to talk about the case history where we used all technologies discussed so far. So active ranging, passive ranging, gyro orientation, and continuous beetle, gyro MWD, and advanced survey management to successfully drill 5 wells for complex plug-in abandonment. And I here would like to show you a few data examples. So from the first wellbore, here you can see the active ranging measured signal. And you can see as we get closer to the target wellbore, the signal increases exponentially. But also you may notice that there is a no signal starting from 500 feet to about 630 feet. And this is most likely because there was no electrical continuity in the target wellbore at this point. Um, Example from the wellbore number 2, and you can see here range distance to target. So this is this plot shows gradient distance measurements, and at the same time you can see the distance measurement from the passive magnetic ranging, which is collected while drilling. And we see great correlation between these two methods, and this is what we expect. This is what we want to see, obviously. At the same time, so well number 3, here we see continuous B total log, and you see that around 500 we have the higher magnitude for the passive magnetic field B total, and you may recall that first picture from the well number 1 where we had no continuity for active ranging. But so here, this is a passive example, and we see that in cases where, for example, we have to deal with a casing break, when there is no continuity for current in the casing, but passive ranging shows this magnetic field at each end of the casing break in this case, and we can clearly see the ranging information from passive shots. So using all these tools in our toolbox allowed us to successfully finish all these 5 wells in the project, and at the same time it allowed us to reduce the duration of the project twice in comparison to the planned duration. At this point, I would like to switch to axis-dependent ranging, and I would like to talk about lodestone at bit while drilling ranging based on the rotating magnet in the drilling BHA. So the source in the drilling BHA is based on the rare earth magnets, and they may be inserted in the near bit sub, or it can be inserted in pony collar if we need a larger source. So when the BHA is rotating, the source creates the sinusoidal magnetic field, which allows us to detect this field from the receiver in the offset wellbore. And this sinusoidal field provides us, enables us better filtering algorithms, which allow us the farthest detection range and higher accuracy of the ranging measurements. So it is detected from the offset wellbore by the specifically designed sensor assembly. The range measurements can be near the bit if we deal with near bit sub as a source. It can work on any drilling assembly. So the intersection types that can be achieved with this tool are such as horizontal to vertical intersection, which is very common. But also we can do multiple horizontal to vertical intersections. We can do we can intersect multiple verticals with one horizontal, or we can do this vice versa. Another interesting example here, what can be done, we can do toe to heel intersection. So what I already mentioned briefly, I believe, is that imagine you have a reservoir remote from the production platform, and extended reach drilling techniques do not allow you to connect that drilling platform with that remote reservoir. But so what can be done in this case is that you can connect two wells, two laterals with each other in order to extend the lateral part, and this can be all connected to the existing platform. Another example here shows the horizontal to horizontal intersection, or even multilateral horizontal to horizontal intersection. At this point, I would like to talk with you about precise interlateral spacing measurements using lodestone tool. And if you're curious to know more details, you can download this SPE paper. But so what this is all about. So you can see that MWD uncertainty can be significant if the laterals are long and closely spaced. So it's not only a collision concern, but as I already mentioned, these interlateral spacing measurements, they're required for frac hit modeling, for batter modeling. So magnetic ranging can help you to measure the distance precisely between the laterals, so you can provide better interlateral spacing information to the frac hit models. Another case history here is where our client, and it is just to cover some of the intersection types I was talking about, and just to show that this can be done, and it was done. So the client in this case wanted to connect two near horizontal wellbores to intersect, to connect it with one common vertical producer. The MWD uncertainty at the intersection area was about 100 feet, while the target was only 1 foot. So obviously we needed to run ranging receiver in the vertical well and the source in the drilling BHA in order to navigate our drilling BHA right into the target. And this was done, and we were even able to collect a shot of this intersection just to see how this looks. And the final case history here. This is about a multilateral horizontal to horizontal intersection that we have done not too long ago as well. Our client wanted to connect horizontal wells, multiple horizontal wells, with each other in order to create hydraulic loop. So MWD was used initially to drill the well bores and get them close to each other. And when we were within the lodestone range, we deployed the lodestone in the target well, and we attached the rotary magnet sub with to the BHA of the drilling well, and we navigated the drilling well right into the target well, and successfully connected these horizontal wells, established the hydraulic communication and mechanical communication. So this was the last case history. And at this point, I'm ready for your questions. And also, we have a magnetic ranging team on the call as well. So myself and our magnetic ranging team will address your questions at this point. And also, please notice the website there where you can go and find more information about our tool specifications, and also my email. So you're welcome to text me anytime. Thank you very much.
Thanks, Georgie. Feel free to speak up with any questions, or if you're more comfortable to drop them in the chat, that's fine. We'll be monitoring that as well.
Hey, Georgie,
Hello?
the photo you showed on that example where you guys intersected that well, how was that photo taken? The photo of the wellbore?
So yeah, this is the downhole camera that was ran into the vertical well bore, and it's basically the side of the casing. This is the picture of the horizontal well intersecting the vertical well bore with the downhole camera at the depths of the intersection. If the question was about the perspective and
Yeah. Let's see. Mike asked in the chat, how close are the survey center to center distances at the intersection points with the various ranging methods?
Okay, so how close are the survey center to center distance at the intersection points with the okay. Let me make sure I understand the question correct. How close the survey center to center distances? Okay, so here we're just talking about. Okay, so I guess the question is basically about the detection range for the tools. So with the lodestone method that we talked about, the specification suggests that the range can be detection range is up to 120 meters, and with Black Shark tool, we can see the offset well 60 meters away, and with passive ranging, it is basically about 10 meters away. But it is not that simple actually, and there are multiple things that need to be taken into account.
Hey, Georgie, this is my question. This is Mike with Moser Directional. My question is actually more regarding the, I guess, theoretical center to center when you compare the surveys between the reference and the offset well. Like, obviously, at the intersection point, the center to center is 0 because you've intersected it. But what do the surveys anti-collision center to center show? Like, how accurate were the MWD surveys between the offset and the reference well compared to what they actually are, where in theory they should be 0 meters or 0 feet center to center?
Yeah. So again, if I understand this correctly, we can adjust the surveys as or different kinds of things we can do. We can, if it is a plug-in abandonment, we just alter the surface location of the target well. Yes, so you're right. In this case, we basically use the MWD survey from the drilling well as the reference, and yes, you're right. This will show 0.
Okay, thank you.
But before the adjustments, it can be something different. It's just because we continuously do adjustments, it makes it 0.
I see. I was just curious on what a typical kind of net adjustment would be required if just based on MWD survey accuracy and with various MAG interference and different BHAs. I'd imagine it would be tens to hundreds of feet. Sometimes you have to adjust cumulatively.
It depends from the job, definitely. Sometimes we're closely located to the target well and we don't see hundreds of feet. But if it is like horizontal to horizontal intersection, yes, it can be, and we would need to have a tool with the longest detection range. It all depends, from multiple factors, and the system which was used, and multiple other things.
Okay, thank you.
Thank you.
Great, thanks, Mike. Next question from Kurt. What are the temperature limitations on the passive ranging technologies?
So in this case, we're just limited with the MWD tool limitations. So because the sensor for the passive ranging will be the MWD tool, and I believe we're talking about 150 to 170 if it is high temp tool. If I recall the limitation for the MWD high temp tool correctly, and I'm talking in Celsius.
Okay, thank you. Next question from Zhang. Hi, Georgie. Have you guys used this for the oil sands drilling?
Yeah. So the very common technology, and we used it multiple times for the SAGD. It was the SMAC tracer based on the electromagnet deployed in one of the SAGD wells. Yep. Yeah, we did.
Good. Thank you. And Elena asks, would you advise the success rates for horizontal to vertical intersection case based on your experience, please? Basically, what are the success rates for your horizontal to vertical intersections?
So basically, what our success rate here would be is
100%. It depends how you look at it. I mean, the old projects we did, we at the end of the day, we never missed this target. We completed this project. So there might be not the intersection, not from the very first attempt. If we're talking about just about this lodestone technology and horizontal to vertical, but the ultimate result at the end of the day, we intersected all of them from what we have done so far.
Good. Thanks, Georgie. Thanks, Elena, for the question. Carrie.
Oh, I'm sorry. Here. Mm-hmm. Sorry, just to carry on this subject. How many attempts does it usually take for this complicated intersections?
Well, with a proper planning, there should be just one attempt, and it should be a success. But if, for example, something missing from some information is missing about the one of the wells, like survey information is not accurate, just because of some of the missing information, there can be a second attempt. But if everything is planned properly and there's no question about the planned phase, it should be just first attempt. Because I would not say that those are complex intersections. In the intersection world, those are probably one of the those are not that complex. They're pretty common.
Next question from Carrie. How far away from your offset do you start seeing them? How do you handle congested drilling in a pad or offshore drilling for collision avoidance?
Okay, so again, there are different methods. So if there is access into the wellbores in the pad, so if we can run the receiver in one of these wells and drill nearby with the magnetic source in the BHA, we can just see just that well that we need to see and pretty much ignore lots of wells around it. But if there is no access, we have to do current injection, and this current may get into the other wells, and we would have to do so-called vector subtraction in order based on the theoretical wellbore position. So it can be very easy, but it can be also difficult if there is no access. But with proper planning at the planning phase, this all can be solved. But if I didn't miss any part of the question.
Well, sounds good. Next question from Pete. Do you know of any operator connecting multiple vertical wells with a single horizontal?
Multiple vertical wells with a single horizontal. I don't know about this particular case, but I would not be able to really, I guess, talk about what our clients would be doing. But at the moment, I don't recall such example.
Okay, next question from Mike with Ensign. Has Scientific Drilling created an IPM tool code specific to ranging?
Yes, so let me just add to this previous question that I just also recall that this might be quite common for the CBM, so CBM clients might be doing this as well. Okay, so and getting back to the current question. So if there is any IPM created for the ranging, so that would be problematic. I mean, of course, we look into the error models for the ranging tools, but I do not think that it would be very easy to call it IPM and use together with some planning software, because basically the ranging is very different. So I should say we estimate the uncertainty. We can provide the percentage out of the total separation for our, so percentage of the, like 5% is our spec out of the total separation between the wells. And of course, as we get closer, this 5% becomes smaller and smaller distance-wise. So yes, we think about the uncertainty. We attempt to model this and look farther into this. But to create an IPM, it might be a discussion that we, as an industry, probably need to have.
Okay, thanks. Next question from Stefano. what are the distances at which the lodestone can detect a casing compared to standard wireline active ranging and standard MWD passive ranging?
Ben, would you mind please repeat this question?
Yeah, no problem. So basically, what are the distance at which the lodestone can detect the casing compared to standard wireline active ranging and standard MWD passive ranging? I know you mentioned lodestone had a longer range there.
Yes, so lodestone has the longest range. We're talking about up to 120 as per spec, 128 meters in our spec. But I believe there was something mentioned about the casing as well. So if the lodestone sensor is in the casing, so it will reduce the detection range. But again, it can be calibrated out. I mean, the effect of the casing shielding can be calibrated out, but yeah, we may expect a reduction in the detection range. So if we compare it with other methods, such as electromagnet, for example, with we expect lodestone to have couple of times at least farther detection range, maybe 3-4 times. It's just all linked to better filtering algorithms of the signal to noise.
Okay. Next question here. This is Sam Abraham from GRG. Can we use this in partial to total loss zones drilling?
Can we use this on partial to total losses? Okay, I see this question. Can we use this in partial to total loss zones drilling? Okay, yes, okay. I guess it might be, if I understand this correctly, is it about like recovering the well? If I understand this right, it can be, yes, it can be used, and it has been done in the past. So we can range to the well, which is nearby, and do so-called twinning or handrailing, if I understood the question correct.
Georgie, this Chandler with Scientific out in Bakersfield. I think that part of that question might also be, do we require fluid in the wellbore to range? And my answer to that would be that no, we can range with or without fluid in the wellbore.
Oh, okay. So it was about drilling fluid losses. Yeah, ranging does not require fluid. Yeah, I mean, again, cannot even think about it. Nope, that wouldn't be the thing of the concern. We can do that, yeah. Thank you, Chandler.
Yeah, thanks, Chandler. Thanks for the question, Sam. Next question from Jesse. Which method outputs the smallest ellipse of uncertainty with no offset access?
Okay, so if there is no access to the target well, which will be the most accurate, right? So when we have no access to the target well, we only can do Black Shark, and I would say this would be the most accurate. Yeah, this is the most accurate method, Black Shark. If there's no access to that's why this is our main tool. It's access independent, the most accurate tool.
Okay, thanks. From Ty, do any of these ranging methods require redundant survey data sets in the target well, i.e. more than just one MWD run per hole section?
Well, this is a good question. I mean, it depends how accurate the first survey is, but redundant survey information is always great. I mean, to some extent, we don't want to have too much information, but yeah, several surveys, 2 or 3 would not hurt. But as long as we have definitive qualified survey, we should be good.
And I'd just like to follow on from that. So ultimately, we've done projects with Scientific where we have intercepted wells that are actually totally blind. So we'll know the surface hole location, and we have an assumed verticality of the well, and we've been able to intercept that well without any surveys in the wellbore. And on the other aspect, we've also done projects where we've had multiple sets of surveys. So had multiple MWD surveys plus gyro surveys, and it's essentially the bee's knees of like the perfect situation. And in terms of uncertainty, it ultimately depends on the specific scenario of the well. Some wells have very good positional certainty, some wells don't, and that is a specific question on a well-by-well basis.
Thank you, Jamie.
Thanks,
Yeah.
Jamie. Georgie, I know you said we clarified there that we don't have to have fluid to make a measurement. We don't have to have the drilling fluid, but does the mud type affect the measurement any?
Yeah, that's definitely a good question, and it all depends from the ranging type you use. But if it is access independent for current injection into the formation, yes, it will. It will affect, and we would have to account for this at the planning phase. Come up with the best configuration for this particular situation for the tool, and this can be addressed for sure. But that's a great question, and this is the factor to account for if we do current injection, for example. But if we deal with lodestone rotary magnet, there will be no difference.
Okay. And I've got another question that came in via email here. Does the well location or the well direction affect the ranging measurements?
So I guess this is a great thing about ranging, that generally not. Ranging is, so we know that magnetic survey is affected by the direction, like east-west horizontal is the worst. Ranging does not depend from this because we are not really based on the Earth field. We're ranging from one object to another, so no effect.
Hey, George, I have a follow-up question on that. So what happens if your BHA, what you're using is magnetized? Let's tell a magnetized motor or a drill collar or so on and so forth. Is it going to impact your measurement?
Well, it's not going to impact, but it's something that needs to be accounted for. So if our receiver is nearby to this magnetized BHA, like really close to this, it's something that we probably want to account for and compensate in the measurements. Or if it's like rotary magnet-based measurements, there may be some things such called as a BHA effect. It's something that can be accounted for with corrections and eliminated after that. But yeah, it's a good point. In some methods, there will be no effect because there is no effect. There is nothing nearby. But in some methods, there will be effect, but it can be calibrated out or accounted for.
Okay, thank you.
Thank you.
Georgie, Ty has another question. He said he couldn't hear clearly earlier when we discussed the lodestone technology. He wants to clarify it does or does not require access to the target well.
Lodestone does not does require access to the wellbore. It's just in that offset wellbore you would need to run the receiver. So it's the longest range tool, but it does require access to the wellbore. Black Shark does not require. Lodestone does require.
Hey, Georgie, I have a question about signal strength and determining distances between wellbores. Can you use signal strength to accurately, determine that?
Yeah. If we're talking about just distance to target, certainly we can use the signal strength. We know. I mean, if we're talking about continuous B total and we just measure that B total, from the signal strength we can estimate the total distance. We may not be able certainly define what is our XYZ relative coordinates, because for this we would need XYZ information from the tool. But from just strength, we can estimate the distance for sure.
So, Georgie, does that mean that if you have the raw survey measurement, you can give XYZ measurement?
Yeah, so raw survey measurement, I guess this is what we call 6-axis XYZ accelerometer and XYZ magnetometer data from the MWD. So in context of passive ranging, this would give us the complete measurement for full complete ranging shot if it's done in the right location.
Okay, thanks.
Okay, and then Carrie's asking, with lodestone, what kind of non-magnet spacing do you need in the VHA to get accurate surveys, or are you required to use a gyro?
Well, so with lodestone, yes, so we use magnetic survey from the MWD, because we need to orient ranging shot. But so, and yes, we are close to the, we may be close with MWD tool to those magnets in the sub, but there are a few things to consider here. So we may be not close enough because for MWD, the tolerance is wide enough. So this this noise for MWD from the magnets in the BHA may not be significant to throw you out of your QC parameters. But at the same time, if we're dealing with the rotating magnet, rotating sub, which is not fixed which two phase is not fixed with respect to the MWD tool, this error becomes random at the end of the day as you collect more shots. And if we are dealing with the like collar, which is fixed with the respect to MWD, in this case, we know for sure what the interference is from our source. We can correct it from the MWD measurements, obviously, just like because we know it's fixed axis wise and we know the strength. So it can be corrected if it is a concern, but it may be not even a concern in many cases.
Okay.
But thank you. Great question.
Georgie, we've also had a couple of questions. Can you go ahead and put your last slide back up that has your contact information on it?
Yeah, certainly.
Or that first one would be fine too.
Do you see it now?
Yep.
Is it?
Yeah, that's fine.
Okay, great.
Okay, let me check my email real quick and make sure I don't have any other questions that I've missed. Okay, I think that covers everything that we've had. Again, everyone, we'd like to thank you for joining in today. As we get this presentation, the recording of it done and posted, we'll make sure we let everyone know that it's available. We also will be conducting another webinar next week. Dr. Josh Wilson is going to be talking about our Halo RSS tool. We'd love for you all to join us again. Since you've been on this call, we'll automatically invite you to the next one, and it'll be up to you if you'd like to register and receive an invite. But thanks again for all of your time, and we look forward to seeing you again in the future. If you have any questions, please feel free to reach out to us.
Thank you very much, everybody, and thank you, team, for helping me to address the questions. And everybody, please be safe. Thanks again.
Thanks, Georgie.
Thank you. I know. Thank you.
Thanks, Georgie.
Thank you.
Thank you, Georgie.